Section 3.8, big fun, algebra and composition with functions. It's pretty straightforward. Again, don't overanalyze, don't make it more difficult than it is. There's lots of letters and symbols and such. So again, what they're doing here, we've just got to get an understanding of what the whole F and G and H stuff means. When they do something like this, there's their definitions. These are listed in the textbook. F plus G of X. That you can think of this as distributing the X. This is F of X plus F of G is all that means. There's different ways to look at these, and we'll get more into that when I start working a couple examples. But you can add F and G and then put whatever your X value is in after that, or you can break them apart, distribute the X, and say F of X plus F of G, or G of X, then plug your X in. When this value is given to us outside the parentheses, it means that value for both of these. So you can go ahead and add F and G if they're simple to add in, then throw your X in. It's less work. Same here, you're just going to subtract, and then here you're multiplying both of them, and you can do the same. Every one of these, you can do this piece first, and then you can add your value in if you want to. When they say FG of X, F minus G X, F plus, that means the same X value for all of them, and they're all going to have an X in there somewhere. So a lot of times it is easier to combine and then worry about your value. All right, then example 1, I worked some of them out, and you see you break it apart. They're telling you what to do here, what this means, and they're just saying, hey, what is this if we don't know our X value? F plus G of X. Well, we take our F of X and we add our G of X until they give us an X value, then we have to combine the two. You add them together, you have 6x squared, you have 3x minus 5x is minus 2x, and a positive 2, negative 6 is negative 4. Just combine them. All right, that's pretty straightforward. The next page of notes that I had is where I explain in a situation like this. Here it makes a little more sense where they're saying, hey, we're going to make it simpler. We know these are all dealing with X. So we're just going to write F plus G, and then we're going to write our number that represents, that X represents. So F plus G of 2. There's two different ways to do them. We can add F and G and get our answer, and then plug 2 in. Or we could work F of 2 and G of 2 and then add our answer. You're going to get the same thing. Composition of two functions, I honestly just think of it as F of G. That O, that little circle, not O, but that little circle, the composition circle, it's easier for me, even I'll slip up and say it in class, because what makes sense to me is to read this as F of G of X and then write it that way. The reason they write it this way is it's less convoluted to get. Here we have double parentheses. Here we don't. So this is cleaner. It looks nicer. That's it. All this means is take the first one and then put the second piece in parentheses. F of G of X. So F of G of X. Okay, let's work a couple. So I chose number 3 first, just to get a feel for it. Show, it says write a formula. I didn't want to write it all out. Write a formula that represents G minus F. Well, here's G. What they can do when everything's out of X, they're all dealing with F of X, G of X, H of X. Then they can just write FGH. So G is 2X. I'm going to do parentheses just to make it clear. Plus 5. What I'm going to do is subtract F. Well, here's my F. I need to subtract the whole thing. This is the only issue with subtraction you got to keep track of, is subtract everything. So what happens is we have 2x plus 5. Then we're subtracting 4x, and we're subtracting negative 3. So we're adding 3. So I have 2x minus 4x equals negative 2x. I have 5 plus 3 is plus 8. And that was number 3 should have been. Yeah, that was number 3. And then 6 deals with the same ones. That's why I didn't write it out again. 6 is still in the same grouping that says here's F, here's G. So now instead of subtracting, they're saying, hey, what's F divided by G? Well, F is, I mean, you can say, hey, what's F? Well, F is 4x minus 3. What's G? G is 2x plus 5. I can't factor anything out. Once I write them where I just replaced F with what it stands for and G with what it stands for, I can't factor anything out. I'm done. That's all I have to do is write that. Now 15, they're saying, hey, let F of x equal 3x minus 5 and let G of x equal x minus 2. Write FG. Well, anytime variables are together, it means multiplication. So again, my F becomes 3x minus 5. That's what F represents. G represents x minus, I'll do this. G represents x minus 2. So now I just have to distribute this. I have to multiply both quantities. So then I do 3x times x, 3x times a negative 2, negative 5 times x, negative 5 times negative 2. And I just have to combine the middle term, and I'm done. That's what those two multiplied together means. All right, now to jump ahead real quick before we move on, in the future they're going to give us F, G, and H. And a lot of times I've noticed what they like doing is they make H F times G. So this would be our H. And then F, they might have done that. 3x squared minus 11x plus, yeah, that's what they did. This is H. That makes it easier. If you catch something like this while you're doing problem sets, you know that whenever they give you H, instead of writing this, you can write this. This is H, F and G. So if they were to give us F or G over H, you know something's going to cancel out. Okay. Now number 30 I wrote down because I wanted to do the two different options. I'm going to make option A the quickest. Option A would be taking F and putting it over G and just seeing if I can do anything first. I can factor a 2 out. Look what happens when I factor a 2 out. 4x plus 2. Factor it out. Go ahead and factor these things. If I pull out my greatest common factor, I see quantity 2x plus 1 on top, quantity 2x plus 1 on the bottom. I don't care what my x value is. They could give me any x value. It's going to be 1/2 no matter what, because that piece is going to cancel out. So I don't have to even type in -3. I don't have to plug in anything. Every now and then, if you just expand and do the work, factor and do the work, you might find out it doesn't matter what the number is. Or you'll find out it can't be done before you plug any numbers in. Option B would be go ahead and plug the 3 in. F over G of -3. Well, if F is 2x plus 1, I make my x a -3. If G is 4x plus 2, I make my G my x a -3. So G of x, F of x, same variable, so the same number. So here I have a -6 plus 1, and here I have a -12 plus 2. So I get a -5, and I got to make sure we can see it. I have a -5 on top. I should write that with it. That's better. And a -10 on the bottom. My answer is positive. 5 goes into 10 2 times. It's the same answer. This was a heck of a lot easier. So go ahead and factor and see if things cancel out. If you can cancel something out, you don't have to plug the number in. I canceled the whole quantity that has x in it out. It's gone. So I'm left with 1/2, and I see that that would happen every single time. No matter what I plug in here, it's going to work out that the top is half of the bottom. The bottom, my denominator will be twice whatever the numerator is, no matter what value I plug in for x. So there's algebra and composition with functions. Not too bad. I didn't bother with a composition yet for this one because I don't have one of those on the test, I don't believe. So, all right, hopefully that helps.